Easy to catch. It just fell. Well, you can see already that higher I drop it from, harder it is to catch, right? Now imagine this is not a stylus, but it is a building that is 20 stories, and the weight of this object is 200,000 kilogram, and it's not falling from 5 centimeter or a 1 feet. It's falling from a height of 95 kilometers above earth. That's just 5 kilometers below the carbon line that's supposed to be the edge of the atmosphere, and passing that qualifies to boost yourself as someone who has visited outer space, and a company Blue Origin is already doing that. But who did this? SpaceX, of course. The latest launch blew mind of the people around the world, and for obvious reasons, it was surreal to witness a 20-story building getting caught by a mechanical chopstick, right? And being a physics teacher, I couldn't miss this trend, and I couldn't be more happy because mechanics is going on for my grade 11 students, and I used the telemetry data provided by SpaceX for the launch to do some data collection, and it was pretty interesting. I'm sharing with you one of the learning experience I recently used for my grade 11 for mechanics. Well, what is the learning experience? The learning experience started with data collection. So basically, we used the SpaceX launch video and we paused it after every 10-20 seconds to make a comprehensive data of two things. One is the speed and another is the altitude. Here in the screen above, you can see the plotted and the collected data, and you can see for the speed value it is kind of a curve that's going up and down. Why so? Let me explain. So basically, I started with the grade 11 with two questions here. The first question was, what is the average thrust till the booster separated from the starship? And the first increasing part of the velocity data points, if you find the gradient of that and if you multiply it with the starship and the booster together, the mass of the booster and the starship together, you can find the average thrust. The calculation is in the screen here. Well, after finding the initial thrust, I asked them that can you find the point where it reaches the maximum height? You will see although the booster engines were off at a certain time in the graph here, but it still kept the upward journey because of the inertia of motion. And although there is a dip in the speed that you can see, but the altitude is still increasing, and that is when it reached 95 kilometer mark. And after that it began its journey downward. When it started its journey downward, it started to speed up again because of the force of the gravity. But soon you will see that speed also peaking up at a certain point, and that determines the terminal velocity. Well, the terminal velocity at such a height is very large when compared to near to the surface of the earth, because the atmosphere there is thinner and the drag force acting on the falling object is lesser. So the terminal velocity was actually very high. Now my second question was, and this was the tricky one, my second question was, what is the average thrust applied by the booster from the moment it reached the terminal velocity to the moment it was caught by the mechanical arm? And like every 11th grader, they like to think simply, but here is a catch in the question. If you just find the average deceleration from the point of terminal velocity to where it gets caught, the answer will be wrong. Let me explain you why. If you think about the free body diagram of the booster, there is an upward force provided by the engine of the booster. There is a downward force that is due to the weight of the booster, and the net force between the up and the down force is causing the acceleration, deceleration in this case. So if you just do m into a, that is 200,000 into, if you look into the gradient, that's 20 meters per second square minus value because it's deceleration. If you just do that, you are doing it wrong, because you are forgetting that the upward thrust is not just enough to provide this much of deceleration, but it's also counteracting the weight of the object. So the correct answer for the upward thrust will be m, that is the mass of the booster, and g plus a, and that gives you a value that's close to 4 weight of almost 700 cars. Well, I did this with 11th graders. They have this in their textbook, and it was a fun class. So go ahead, if you're teaching mechanics, try this activity with your students and let them explore physics.